These notes are an introduction to a protractor. We're going to first start off with a bunch of definitions. The first is array. An array is a part of a line where there's an endpoint and an arrow. And we name our array starting with the letter that is at the endpoint and ending with the letter that is at the arrow. An angle is a union of two rays that share a common endpoint. So here we have the ray ND. The ray symbol on top, and we have the ray DB, again with the symbol of the ray on top. And we name the angle by either using one letter, if the angle is not ambiguous, naming it with one letter, just the D, or by using all three, NDB, where we need to make sure that the middle letter is always the vertex of the angle. So just to label that, this is the vertex. Now with angles, we have a number of definitions that we need to talk about. One is a straight angle, and a straight angle is simply a straight line, meaning that it's 180 degrees. So a line is an angle, it just has a measure of 180 degrees. We also have linear pairs. Linear pairs are where I have two angles that make a line. So they share one side of the angle. They share one ray. Linear pairs add up to 180, and hence the linear, which means that they're also supplementary. However, it is important to note that not all supplementary angles are linear pairs. For instance, this angle and this angle, we'll say this is 120 and we'll say this is 60. These two angles are supplementary angles. They add up to 180, but they're not a linear pair. They don't share one side of the angle. They are two separate angles. They're not connected physically. The last part of these notes are actually on how to use a protractor. So you may have done this in middle school or in Math 1, but just a quick refresher if you haven't seen this before. When you're using a protractor, which is the tool we use to measure angles, you always want your vertex, so that's D, to be at the middle point on the protractor. So you want to line it up so that your vertex is at the middle point and one side of your angle, doesn't matter which side, but one ray of your angle is exactly on that line, that flat line. So that one ray actually starts off at 0 degrees. And then you read your angle. So my angle here is at about 31 degrees. Now, I could have read the angle this way, in which case, again, I am still making sure that my vertex is at that middle point in the protractor and that my ray on this side is indeed flat to the line at the bottom of the protractor. And in this case, I'm going to read the numbers on the outside because I always count up. So 0 up to 31. And in this case, measuring it this way actually is easier because there are more indicators on the outside here for the 0 to 180 in this direction.